Hi, I'm Dr. De Bruin, and this is a quick walkthrough of how to answer an exam question that's mainly from the equilibrium topic of AQA A-level Chemistry, but it does kind of cross over a little bit into amount of substance as well. In this question, we're asked to calculate a value of Kc for the hydrolysis of an ester, methyl propanoate. What's going to make this a bit more tricky is that not only do we not have the concentration data, but we don't actually even have the molar data. So we have the moles of one of the products, but the reactants are given to us as masses. So this is what I meant when I said it was going to cross over a little bit into the amount of substance topic. So to start with, I'm going to use that mass data together with the masses Mr. Mole equation to work out my initial moles of methyl propanoate and water. So if I quickly calculate the relative formula mass of methyl propanoate, I can see that that's 88 grams per mole. And I can then do 100 grams divided by 88, and that tells me that I started out before the reaction happened with 1.136 moles of my ester. And then I know that the relative formula mass of water is 18, so 10 divided by 18 tells me that I started out with 0.555555 moles of water. So those are my initial moles, and they're going to go into my ice table. I'm being a little bit lazy here. I didn't write out the full names of all the substances. I've just put ester, water, carboxylic acid, and alcohol. So to begin with, I can put in the values that I've just calculated and also 0 for my two products. And then they've told me in the question that at equilibrium, I had 0.1 moles of propanoic acid. So I know that my propanoic acid has increased by 0.1 moles. And therefore, if I look at my symbol equation, I can see that there are no coefficients anywhere. So everything's just in a 1:1:1 ratio. So therefore, my alcohol has also increased by 0.1 moles. And therefore, that's going to have an equilibrium amount of 0.1. Then I can go back the other way. For every 1 mole of product I've made, I've lost a mole of reactant because they're in this 1:1 ratio. Obviously, if they weren't, I would need to be using the coefficients. So therefore, I can say that water has decreased by 0.1 moles, and so has my ester. And therefore, my final amounts of those are going to be 0.456 and 1.036. So now I'm going to use my Kc expression, but the thing is, Kc needs concentration data. And I don't have a volume here. So if they'd told me that this is happening in 0.5 decimeter cubed or 5 decimeters cubed, I would divide these molar amounts by that volume, but I don't have one. So it looks like I'm a bit stuck, but actually I'm not. So if I just used V as the volume, just so you can see what I'm doing here, when I write my Kc expression, it's going to look something like this. So I've got products on the top, reactants on the bottom, square brackets everywhere, no powers because I don't have any coefficients. If I now substitute in the numbers that I've got, you'll see that I've got 2 divided by V on my numerator and 2 divided by V on my denominator. So actually, they're all just going to cancel out. So you can only do this with an equation where you have equal numbers of moles on each side. But if you do, then it doesn't matter that we don't have a volume, we can just calculate it anyway. So I get a value of Kc of 0.0212, and then also, because we've got equal numbers of moles on each side, my units for these would also cancel out. So actually, I don't have any units at all. Thank you very much for watching, and I hope you're enjoying these exam walkthroughs. If you are, then don't forget to like and subscribe, comment to tell me which topics I should cover next, and also share the channel. And I'll be back soon with some more A-level chemistry resources.